Now this one is also very, very famous example called Kelly strategy. Okay? By introducing this example, you will know how to gamble in Las Vegas using the Kelly strategy. Kelly strategy is the strategy you use, actually, some of the gamblers they use, and they actually find out this is a very good strategy. So now we're going to talk about Kelly strategy. So what is Kelly strategy? Consider there is a gambler, okay, who at each gamble either wins or loses his bet with probability P of 1 minus P, okay, independent of earlier games. It's okay to be independent because this is independent game you play. So when P greater than 1/2, a popular gambling system known as the Kelly strategy, okay, is to always bet the fraction 2P minus 1, the fraction, okay, 2P minus 1 of the current fortune you have. Suppose you gamble, and then you lose and you win. The current fortune you have actually changes, right? So based on the current fortune you have, you just invest 2P minus 1 of the current fortune you have. And then you bet on the top of that. So compute the expected fortune after n gambles, starting with X units and employing the Kelly strategy. Now we're going to follow this strategy and see what kind of money we're going to get eventually. Expected fortune after n gambles. So we say, why we say expected fortune? Because you may follow this strategy and you start with the same number of money. Their randomness, agree? So if I take 100 folks, they start with exactly the same amount of money. They follow exactly the same strategy. They might turn out to be, each one of them have different number of value money left after n gambles. Then you add all of them together. That is called expectation. Am I making sense? So that's to answer your randomness question. Okay, so this is stochastic process. You have random realizations. Most of the time, like we focus on the expected reward. Okay, based on how many realization you have or how many replications you do. So now, suppose we have a round. So let's denote A to be the fortune. At the beginning of a round. Round means just the one round. You play the game and then you either win or lose. Okay. Now what if he wins? Okay. If you use the fortune at the beginning of a round, what's the probability of winning? After, if he wins, what will be the money he got? He bet, because we are following the Kelly strategy, we bet 2P minus 1. So after he wins, he will get 2P minus 1. Okay? Okay? And what if he loses? Lost. Lose. Lose is 2P minus 1. Okay? And this is P, and this is probability 1 minus P. Okay, he bet. He bet this money, and then he get this money, additional this money back if he wins. You bet $1. If you win, you have $1, and they will pay you $1. Because you put $1, he put $1, right? And then if you win, you just take that $1. If you lose, this $1 goes to the other side. We assume this is you bet, and it's not like you have twice payout. This is equal payout. It's okay. So this is a problem setting. So what is the expected fortune at the end of this run, a run? Okay. So you have A. A is the beginning of the money, right? Okay. Then A plus, then you have 1, not 1/2. This is not equal. So this is, you have P, winning probability, then times A times 2P minus 1 plus 1 minus P, okay, times oh, here you need to minus, because am I right? You need to minus, then A 2P minus 1. So this is expected fortune after at the end of the run. Because in the beginning you have A, right? In the beginning of this run you have A. And there are two possibilities. P, you win. If you win in addition of the A you have, you actually get this money. If you lose, probability is P, you just minus, you lose this amount of money. Is this clear? Because in the beginning you have A. In the very beginning you have A, right? Before you play, you have A, current fortune, at the beginning of this run. Now after you play, you have probability to win. And the win, you will add this amount of money to the fortune you have. Lose, you are going to subtract this amount, this is the probability, from the fortune you have. This is the expected payout for this play, plus the current fortune you have. Is this clear? Okay. So if we play with this a little bit, this will become A 1 plus 2P minus 1 square. Okay. So net xk to be the fortune after the case run. So using this relationship, we are going to have expectation of xk plus 1 given xk. This is actually equals to xk times 1 plus 2p minus 1 squared. Is this true? This is one run, right? This is one run too. But we are assuming we have precedence relationship. Just we have xk right now. Now we're going to play. What is the payout? Is xk plus this. This is expected payout of this run at the end of this run. That's xk plus 1 given xk. And now we were given that in the beginning it's x unit, smaller x. So expectation of x1 is actually, so this is x0. This is the current money you have. And then after one play, what do you have? It's actually x times 1 plus 2p minus 1 squared. And using this equation and this precedence relationship, we will be able to get after how many play? how many plays we given? N plays. So what we have is expectation of xn is actually equals to x times 1 plus 2p minus 1 square, and this is the power n. Okay? This is x1, x2, and xn.